Hey guys, I hope you're doing well. We are going to be doing our last module right now. Congratulations on making it through the year in pre-algebra. Our last module is the Pythagorean theorem, and I know that a couple of you have experience with this already. We are not going to go over the first page. That is really confusing. However, I do want to let you know that I did post a video from the textbook company on this page. It does explain it. It kind of shows you why the Pythagorean theorem works and all that you need for it. But essentially what you need to know is that the Pythagorean theorem says that when you have a right triangle is one, as you know, that has a right angle, one right angle. When you have a right triangle, the Pythagorean theorem states that if you have a side, let's call it side A, and a second side B, then, and C is the hypotenuse, that it's the side that's opposite of the right angle, and it's also the longest side. So that's called a hypotenuse. Okay. So the Pythagorean theorem states that you can find the measures of each length of the sides of a right triangle using the following formula: a squared plus b squared equals c squared. And so that will always work in a right triangle. It doesn't work with any other triangles, just right triangles. So it must have one side that is a right angle, okay? The other thing that you need to know is that the c squared represents the hypotenuse again, that side that's opposite of the right angle. It's always going to be the longest side, okay? It's always going to be the longest side. And the a squared, or the a and the b sides, they're kind of interchangeable. This could be a over here, or it could be b. This could be b, or it could be a. Those two don't matter, but it's important that your longest side is going to be the c squared. That's very important. And also that it is opposite of the right angle. Okay? That's just like the definition of a hypotenuse. Okay? All right, so that's the stuff that this theorem and this example on page 693 is going to show you. And please watch the video from the textbook company that I included in your notes so that you can understand it. But essentially, we're going to show how this theory works, okay? So it says you can use the Pythagorean theorem to find the length of a side of a right triangle when you know the lengths of the other two sides. So we know that a squared plus b squared equals c squared, and then we can find that missing side right here, which is called the hypotenuse, and it's c right here. We can find that length. So like I said before, the a and the b can be interchangeable, doesn't matter, but I'm going to consider that 7 inches as the a and the 24 inches as the b, and I'm going to go from there. Sound like a plan? All right. So according to the formula, I have 7 squared plus 24 squared equals c squared. That's me just plugging it into the formula, okay? And so I know that 7 squared equals 49, plus my 24 squared, if I do the math, 24 times 24 equals 576, and I know that's going to equal c squared. Got it? So I'm going to add these two together. When I do my math, I calculate this out to be 625 equals c squared. Now, I don't want to know what c squared is. I want to find what c is. And so in order to find what c is, I've got to take the square root of it, right? Remember, the square root is when you ask what number times itself gives you that answer. It has to be the same number, right? And so I'm going to take the square root of both sides. The square root of c, I'm going to say what number what times what equals c squared. Well, c times c equals c squared, right? So c is going to be in here. So the square root of c squared equals c. And the square root of 625, what times what equals 625? Yeah, 25. So 25 times 25 equals 625. So that side, c, is 25 inches. Okay, you will need to use a calculator for some of these, but remember we estimated and we came up with all those square roots a long time ago. That chart will come in handy right now if you don't have a calculator with you, but remember we ended up finding all of those perfect squares and everything like that, and when we did cube roots and everything, that will definitely come in handy again when you're using the Pythagorean theorem. But that's how essentially you solve it. That's all there is to it. Let's try another one, okay? Go ahead and pause the video, try this one on your own, and we can go from there, okay? All right. You might have noticed something if you tried it on your own. You might have run into a little bit of trouble and you might have been a little confused by something. Because right now, I've got a squared plus b squared equals c squared, which is my Pythagorean theorem. But I'm noticing something here. I've got an a down here, and this is actually a c. Well, how do I know that's a C? Well, first of all, it's opposite of my right angle, and it's the longest. It's the longest side here, so I can see it, and I can see that it's the longest side. But the main giveaway is that it's opposite of my right angle. So my B is actually over here. Does that make sense? So you're going to have to check yourself on that, because obviously you can have a very, very different answer if you mix up your numbers on what is C. What's A and B, like I said, are interchangeable. They don't matter. But the C must always be opposite of the right angle, and it must always be the longest side. Okay, so let's plug in my numbers now that I identified which one is a squared and which one's a, which one's b, and which one's c. So I've got a squared, which is 12 squared, plus b squared equals 15 squared. Just plug it in into the numbers that I know, right? So I've got 12 squared is 144, plus b squared equals 15 squared, which is 225. You with me so far? All right, so I want to get the b squared by itself. Essentially, I want to get b by itself, right? So I've got to subtract 144 from both sides. And I'm left with b squared equals 81. All right, but I don't want to find what b squared is. I want to find out what b is by itself. So in order to get b by itself, I have to take the square root of both sides, because whatever you do to one side, you must do to the other in order to keep it equivalent. And the square root of b squared equals b. And the square root of 81, I've got to ask myself what number times what number equals 81. Has to be the same number, and that is 9. So b equals 9 centimeters. Make sense? Okay. Here's another example for you guys. I suggest that you find out which is A, which is B, and which is C first before you do it. Pause the video, go ahead and solve it, and we'll go from there, okay? I'm going to make this A, this B, and of course that's C because it's opposite of the 90-degree angle. So I know that 30 squared plus 40 squared equals C squared, right? So I've got 900 plus 1600 equals c squared, and that equals 2500 equals c squared. And at this point, I take my square root of both sides in order to find out what c is, and c equals 50. So c equals 50 feet in that instance. Now let's move on to the other problem. I'm going to identify my hypotenuse first, and I know that's across from the right angle. So my 41 inches is my C. So that means that this guy can be my A, and this guy can be my B, and I'm actually trying to find out what B equals. So A squared plus B squared equals C squared. That's a C. Squared is my formula. And so I know that 40 squared plus B squared equals 41 squared. 40 times 40 equals 1600 plus b squared equals 41 squared is 1681. And so I'm going to subtract 1600 from both sides to get that b ultimately by itself, right? So I'm left with b squared equals 81. And so I'm going to take the square root of both sides in order to get the b by itself, and I'm left with b equals 9 inches. Sound good? Not so bad, right? All right, so now is where it gets a little bit complicated, and I do have another video on this from the textbook company that I included. So if you don't quite get this when I explain it, please, please, please watch the textbook video. I think that he explains it very, very well. So you'll get to see this example 3 separate times, and hopefully by that point, it'll kind of sink in on how to solve this problem, okay? It says you can use the Pythagorean theorem to solve problems in 3 dimensions. We love it, don't we, right? A box used for shipping narrow copper tubes measures 6 inches by 6 inches by 20 inches. So we see that here, 6 by 6 by 20, right? Okay. What is the length of the longest tube that will fit in the box, given that the length of the tube must be a whole number of inches? What they're asking for is they want us to put in a copper tube. And of course we know that the copper tube would be, the longest copper tube would be able to fit in diagonally this way. So essentially I want to find out what that R measurement is. So I need the copper tube to fit in from the very bottom of, the front of the box to the very top of the back of the box, and that's going to be the longest copper tube that can fit, right? So I want to find out what R is ultimately. In order to find R, I'm noticing that obviously I want to use the Pythagorean theorem, right? That's what chapter we're in. And I can see, if you kind of stick with me for a second, I can see that that is a hypotenuse right here of a right triangle. Do you see that? That R is a hypotenuse that's made up of a right triangle that's right here. So I can essentially use the formula a squared plus b squared equals c squared. But what I need for this formula is the c squared is actually the r. Does that make sense? Because that's the hypotenuse. So I'm going to replace that with r. A squared, let me say that a squared would be like this guy right here. That's that height that matches this height. Does that make sense? So that would be 6 squared plus, and my other side is right here, and that's s squared. Well, that doesn't help me, does it? Because I don't know what s is. Okay, so let's go back, and we know that this is ultimately going to be our problem. But I got to do something to find out what s equals, right? Does that make sense to you? I got to find out what s squared equals. Okay, so we know we're ultimately going to do that problem. But I've got to do a different problem first. And in this, if you kind of like flip your vision in here, I'm seeing another right triangle. Do you see it? Okay, right here. That's S, this guy here, and this guy here. Do you see that right triangle right there? It didn't really make a box, but it essentially, like, it is a right triangle because it's the corner of the boxes right here. And I'm not doing a good job of drawing it, but this is a right angle right down there in that bottom because that's the bottom corner of the box. And so if I look at this angle, I can also use the Pythagorean theorem. Okay, let me talk about this guy right here. It would be, the formula is a squared plus b squared equals c squared, right? And my c squared is essentially the s. Do you agree with me? Because that's like opposite of the 90-degree angle. Are you with me on that one? Okay, so s squared is that. And then my a can be this length of 20 inches, so 20 squared, plus b is going to be this length right here, which matches this length over here, which is 6 inches, so 6 squared equals s squared. So I can find out what s actually is right now, right? Does that make sense? Do you see it? Okay, good. Okay, so 20 times 20 equals 400. Plus 6 squared is 36 equals s squared. That's an s squared. Okay. If I add these together, I get 436 equals s squared. Now, typically at this point, I would want to find out what s is, and I would find the square root of 436 and the square root of s squared. Do you agree with that if I wanted to know what s is? But I'm noticing that in my formula over here that they want s squared. So why do an extra step? I already know what s squared equals, right? So in this case, I can just plug it in. So I can say s squared equals 436 because I just kind of went do and plugged it in. Got it? So I'm going to rewrite this problem with my s squared. So I've got 6 squared. So now let me go back and trace out what we're doing right now. We're going back to this triangle, right here, this right triangle, and I ultimately want to find out what r is, okay, to find out the length of the tube, or the length of the copper tube that I can put in, right? And so now I know what I'm doing. A squared plus b squared equals c squared. This is my a, that s is my b, and my r is my c. Got it? So I did a squared plus b squared plus c squared. I know that the a equals 6 because it matches up with this guy over here. I know that my s, I don't know what it equals by itself because I didn't do the square root of it, but I found out from that other work that s squared equals 436, and that's what I needed for my problem, so I'm going to keep it that way. And I know that that's going to equal r squared in the end. So going back here, 6 squared equals 36. So I'm left with 36 plus 436 equals r squared. You with me there? Okay, so 36 plus 436 equals 472 equals r squared. And this time I do want to find the r. So I take the square root of both sides, and I'm left with r over here. And the square root of 472 is about 21.7. Using my calculator is about that. But you know how to estimate them. Remember, we did all that work a couple of units ago. But it was about 21.7. Okay, so that's the length of this guy right here. I'm going to go back to the question for a second. And it says, what is the length of the longest tube that will fit in the box, given that the length of the tube must be a whole number of inches? Well, whole number in inches. Right here, I wanted to find whole number, and typically I would round up to 22, right? But in this case, I can't go bigger than the box. So the longest that I can make it is 21 inches. Even though I would typically round up, I can't in this case because it wouldn't fit in the box, and they want to know what is the longest tube that can fit. So the longest tube that can fit is 21 inches. Okay, I know that was a lot to take in. The good news is that we have another example right here, and I have another example in your slideshow. On one of the next slides has something from the book company on it. Okay, so we're going to do the same type of problem, and it says Tina ordered a replacement part for her desk. These geese are crazy today. Sorry about that. Tina ordered a replacement part for her desk. It was shipped in a box that measures 4 inches by 4 inches by 14 inches. What is the greatest length in whole inches that the part could have been? Awesome. Same exact problem, actually, except for different numbers, right? Ultimately, what we want to find is this r right up here, right here, this hypotenuse. And we can see we have a right angle there, right? And so essentially, we want to find a squared plus b squared equals c squared. But my c squared is actually my r. Got it? This angle right here is what we're trying to find. And in order to get that, I've got to take my a squared, which is this height right here, which matches this height, which is 4, plus I need this length right here, which happens to be my s squared. So that's my one triangle, but in order to find my s, I've got to come down here and look at, well, I should pick a different color, right? I've got to look at this triangle that's kind of laying on the bottom of the box. Okay? That's the triangle that I need in order to help me find the s. And I can't really draw it in here. That is a right triangle because it's the corner of the box. They do a much better job showing this right angle that I'm giving you right now in the video from the textbook company. So please, please, please watch it if you're having trouble with it. But now I've got to do a second problem in order to find out what s equals. Now, s is my hypotenuse for this case because in here, s is opposite of that right angle. Got it? And so I've got a squared plus b squared equals c squared, but I'm just going to replace that with s right now. Got it? Because s is that hypotenuse. Okay? All right. So my a squared could be 14 inches. Right here, that bottom. And then this side over here matches up with this 4 inches over here. So this is 4 inches squared. Does that make sense? And that's going to equal s squared. Okay? So 14 times 14 equals 196. And then 4 squared equals 16. And that equals my s squared. Got it? All right, if I add those two together, I get 212 equals my s squared. Now, typically, if I want to find out what s equals, I would take the square root of both of these. But I know over here that this guy wants my s squared, so I'm not going to go any further and do extra work. I'm going to go back to my other triangle now, and I'm going to flip my thinking, and I'm going to go to this stand-up triangle that kind of cuts through the middle of the box. And I'm now looking for that r. Got it? I want to know the value of that r right here. So I ended up using this. Height was 4 because it matched over here, right? So that was 4 inches squared. Now my s squared, I already know, is 212. So I'm going to put that in here. And I know that that's going to equal my r squared because my formula was a squared plus b squared equals c squared. So I know that 4 times 4 equals 16. So I've got 16 plus 212 equals my r squared. You with me on that? Okay. So that equals 228 equals my r squared. And in order to find out what r equals, I've got to take the square root of both sides because whatever you do to one side, you do to the other. And I'm left with r over here. And on this side, I'm left with the square root of 228. Using my calculator, it's about 15.1 inches. Now, let's going back to the question. It says, what is the greatest length in whole inches that the part could have been? Well, it can't go over 15.1, and I want a whole number, so it's got to be 15 inches is my final answer of how long the part could have been. Okay? Again, I hope that helps. I feel like I explained it the best that I possibly could. But what I want you to do is watch the video that I provided on the other slides to help you understand it a little more. Okay? Your work for today is going to be the guided practice. You can ignore how they do it, like, you know, how they leave the boxes on here for problem number 1 and everything. You can ignore the boxes and do it on a separate sheet of paper, however your brain works, if those boxes confuse you, okay? And then over here, I just want you to do the independent practice. You do not have to do the hot problems today. If you would like to challenge yourself, go for it. You can choose your challenge and you can continue it. But I just expect you to do page 696 and 697. Got it? All right, my friends. Again, you're gonna see the video on like the 3D rectangular prism and how to use the Pythagorean theorem. But remember, I'm also going to show you a video on this. Okay. Here's the thing. You don't actually have to understand the video for this part when he cuts out triangles and kind of lays them out for you. I don't expect you to necessarily understand that. It's just a picture of a visual for you so that you can understand why the Pythagorean theorem works. But don't let it confuse you. Don't get overwhelmed by it. If it, like, just be like, wow, that's really cool. And understand the math part of the Pythagorean theorem. You don't have to understand why it works. It was just there to kind of explain things a little bit and say, hey, they're not lying about this. It really does work every time. Got it? All right, my friends, I hope you have a fantastic day, and I will see you later. Bye.